I was down in Tampa yesterday, Wednesday. Yeah, 90 degrees foundation presentation for the alumni. It was fun. But 90 degrees, 2.68 on Wednesday. Wow. Unbelievable. Can we start with the infrared? Want to make blue that you had? Yeah. Excellent. Cheers. Okay, we'll get started. Thanks for coming to the weather discussion. Had quite a week. We're not going to talk about it all unless other people want to volunteer, but this is an infrared water vapor satellite movie that Pete's put together for the last week. I'll let it run once and you'll see some interesting features, and I'm trying to get the marks on when I want to start pointing them out. But it's been a very stormy period across North America, and especially waters to the east in the North Atlantic. So we're going to watch a couple of things develop. This is his storm number 1, gets really revved up south of Greenland, and that's early in the week. That's on Monday, or the 20th, it's before Monday. Here's storm number 2, does the same thing, gets nicely revved up. And then more recently, this is the event I think that came through and had the tornado through New Orleans, and then some heavy weather across Texas. Kelton was telling us about it. Also, I was in Florida on Wednesday, and we had a really good thunderstorm Wednesday night into Thursday, so that was great. Walking around in shorts and sandals in the heavy rain. It's hard to believe it was March, you know. And then people were saying, "Would you like to move here?" I said, "No." But I did like that day. That was fun. So it was really neat. Now, let's watch some other things on this feature that Pete pointed out to me. One of them comes in around the 23rd. He was terming it the Great Red Spot, right here in the water vapor. There it is. There it is. Migrating across the Ohio River Valley. It's one of several little spots. And so when we watch this again, you're going to see a whole string of pearls emerges out of this sort of southwesterly directed flow. Or north-northeasterly, I guess it is. It's directed to the southwest. It'll come out of this one. Look at little things like this that show up on these shear lines. Okay. Now, that's just a little bit of a prelude. They get better. I think they start to come in here. This is the shear line that's going to wrap up. 1, 2, 3. There's the Great Red Spot. Look at that. Isn't that awesome? Whole little string of them kind of coming across on the western periphery of the most recent storm that came through. So the one that brought all the tornadic weather to Texas and Louisiana and the thunderstorms to Tampa. So really nice. And I don't know, I'm not prepared to say this is unusual. I would say that we see those kinds of features a little more frequently, though, in the Pacific Basin than we do over continental North America. And I look for them every day to see, because I really like to watch these things. Can you stop it, Pete, a couple of times? Maybe go back a couple? And we'll kind of step through and try and count the number of very small-scale cyclonic disturbances that we see on this portrayal. Okay, but it's probably a good place to stop. So here's a really strong shear line, and remember, this is the water vapor imagery, so this is upper troposphere, dry as a bone, and so we see a nice tropopause fold right in there is most likely what it is. And we can maybe 23rd, about 24th 0Z, we'll look at an upper level map and see what we understand about that. Right here in western Kansas, there's the first little roll-up, and clicking through, you can see the whole line is kind of getting kinked, right? Same thing's happening on the downshear side. Here's the beginning of the big red spot Pete was talking about. But look at the geometry there. There's a little scallopy geometry on that line, and there's a disturbance wrapping up there over the panhandle of Texas and Oklahoma. Keep on going, Pete. There's the spot. Here's disturbance. Watch now in the interior of the cold air. There's one here over Iowa. Look at that. Just one after another. 1, 2, 3, 4. Okay? I think there'll be more than that. There's the one in Iowa moving across Missouri. So really, really active period of small-scale disturbances. And this is right near the end of almost at the current time.
We're going on up here too.
Yeah, so now let's go to the radar reflectivity peak that you showed earlier. And that's also the same amount of time almost?
It starts on Monday and ends yesterday. I didn't have a chance to review it today.
Okay, it doesn't matter. We'll see all the interesting things on Monday through then. And we're mostly looking around our region, right around the state of Wisconsin and adjacent states. So here's the development of the main disturbance for the main weather. There's the tornadic line that went through Texas, and then New Orleans it'll come through. And of course there was one fatality there at least, maybe more, I hope not more, and got kind of interesting. And I was watching this on Wednesday night thinking, oh, this is going to be great for Thursday morning. It's pretty good. Now look at all the little disturbances you can see here, the swirlies, and we'll go to a close-up on this too later on. I guess there's just the one. Maybe we need to go to the close-up view, Pete, to see them even better. So let's do that. And you can see where they occur in the context of the whole week's weather. They're on the northwest side of the main event that occurred down to the south and east of us. But you're going to see a whole bunch of small-scale. Be prepared to stop it, Pete, so we can kind of catch it in the act here and there. Okay, so we're seeing a surge. I'm trying to remember which ones. This one here starts to look like an obvious circulation center. Oh, it's this one here, I guess. Okay, so we see some features around that. That was the heavy rain on probably, what was that, on Wednesday? Tuesday night to Wednesday?
Well, it's the 23rd, so Wednesday morning.
Okay, so let's step through. There's a circulation center, and it migrates to the northern part of the state, northwest there, and it comes back around and gets a little bit more shape when it moves into Minnesota. You can see it.
Actually, just a little south of there. If you go back a little. You can actually sort of follow it.
Yeah, and here it comes again. It really manifests itself in Iowa. I think that was one of the ones we saw in the string of pearls there. But so even in the reflectivity, these features were manifesting themselves as local circulation centers. It's really been an active, kind of interesting period of time over the last several days. And much of it I missed down in the tropics. But we'll see in the forecast that there's a chance for a continuation of this sort of situation of fairly constant battery by inclement weather of one scale or another over the next several days. Look at that, it's a beautiful little cyclone that goes through Iowa. Maybe for the Iowa State Cyclones, who unfortunately beat us last week. So.
Yeah.
Okay, so let's go to our large-scale satellite movie, if we could, Pete. Our regular beginning of the Weather Watch. Thanks for putting these together and having them ready. They're really pretty neat about this week's weather. So here's our visible image, and we still have this thing churning away over the North Atlantic Ocean. Just awesome, isn't it? And these are all low clouds. You could really tell when you look at the infrared satellite imagery. Everywhere where it's clear, it gets bright, it gets really dark black quickly when the sun comes up. And all these places stayed the same shade of gray, so they're not changing temperature at all. And they're low clouds. The ceiling is about as low as you ever get it around here, I think, today. Has been for the last couple of days. When I landed yesterday, you got out of the clouds and you were just about on the ground, which is rare. I mean, in my experience, landing in Madison, that doesn't happen so often, but it did yesterday. Widespread clearing across the western half of the country, I'd say, broadly. This is low stratus clouds on the backside of this major cyclone, which is not as well, doesn't present itself as nicely looking as these ones that have kind of spun up further to the east, but it's still a pretty decent storm. It's dealt with a lot of substantial heavy weather across the southeast U.S. over the last couple of days. And most of the precipitation now we'll see in the radar, particularly maybe right at this moment, is far enough offshore that you don't even see it really picked up by our land-based radars. But you can imagine and extrapolate from prior times that this is pretty heavy weather, and now at sea, not any longer over the land. And we're not far from a pretty nice clear spot here, but we're not going to see it, I don't think, today. That's just unfortunate. That's the way it is. Okay, can we take a look at the radar? And so, yeah, here's the evidence here. You've got a radar at Chatham, I think, near the elbow of Cape Cod. That gets out far enough to see some of this precipitation. But all of the stuff that's well offshore of the Carolinas and the Mid-Atlantic is too far away now. But it's probably speckled with 45, 50 dBz type precipitation, as it was across the Gulf of Mexico, with better resolve. This band here, we'll look at the surface maps in a minute, is the sort of leading edge of that whole cloudiness, where suddenly over the state of Michigan, it's quite clear. But it's, this is the front edge of the clouds, and it's the part of the clouds that's most substantially precipitating anyway. It's precipitating back over La Crosse, Minneapolis area as well. We'll see in a minute what form that precipitation is taking. My guess is snow and mixed snow or rain, or just rain further to the east. And then the same down across the central part of the lakes in Indiana, Ohio, parts of Pennsylvania and New York. This is probably lake effect type of precipitation, but we'll see what type it is when we take a look at the surface off in a minute. And then, interesting set of reflectivity returns here across Kansas. Don't really know what's going on there. I can't remember if there was an obvious cloud signature to that, but I guess there has to be. We'll see also in the odds what that's doing. Okay.
John,
yes.
Just to clarify, if you ever wanted to try to look at some of the precip offshore, you can always look at GPM, the iMerge product.
Oh, is that right?
Yeah, so if I mean, it's not as instantaneous or frequent, right?
Yeah.
But right now you can nicely see how heavy the precip band is offshore.
How do we, do you know
Just Google quickly the GPM iMerge.
Oh, that's great. I didn't know that.
And just, yeah, click on that link. and you can loop it or you could just look on the latest image. So this was, 12, just after 12Z.
Yeah, okay, so,
But you can get a better feel for it, what you were talking about earlier.
look at the difference. Yeah, see, this is what one has to suspect just from extrapolation, but you don't have to suspect that this is an observation. Oh, that's great. Yeah, so all the heavy weather is offshore. That's neat. You do regions too?
Not from their quick look,
Okay. That's really nice.
but on this, but you can loop it too with, the animation, but it's a pretty long animation.
Okay.
So I don't know if you want to go through it now, but it's there for your reference.
Great, that's great. It's called iMerge.
Yeah.
I'll add that to the weather watch.
Okay, yeah, thanks. That's great.
Not to bring up any old wounds too, but there's a Python package for downloading and plotting that in real time. You know, you can set it up on the.
It is a regional, yeah.
Oh, is that
regional
right?
one, yeah.
Is that gonna displace the Gempack one? Or the Netscape one that's already out there? All right. Oh, that's great. That's great. I didn't know this existed. Oh, this is really great to see these storms in their full glory.
It's also a TC and
Oh, yes, right there, right?
yeah.
And what's this thing
It's
off the
hard
west
because
coast of
you have a lot
Australia?
attenuation,
Is that a tropical
but
cyclone at this time of year, or is it a little too late for the season?
It's an invest area.
Oh, it is, okay. Okay. Yeah, very interesting. Oh, that's great. I didn't know this existed. I'm glad I didn't know.
That's great.
We can talk to you tomorrow about this more after.
Okay.
It's
Thanks for that tip,
especially
Angela. That's
with
great.
three-dimensional.
Now let's take a look at where we're going to go next. I guess the west coast? No, the surface ops. Let's do that before we leave the continent. That is wonderful. So I think I'm interested in seeing first in our own state what type of precipitation is falling in that band that at the current moment, this is maybe an hour or so old, was draped across the eastern part of the state. It's snowing up at Superior, 33 over 30, 41 over 35 at Green Bay, warm enough to rain everywhere in the state except at Superior, and maybe just to the south. Is that Wausau? I don't know if it's far enough south. And then light snow in Duluth, 39 over 23, wow, 34 over 23. Light snow, is that Hibbing, Benji?
Well, it's International Falls.
International Falls. I thought that was there. Dang it. All right. So light snow across southwestern Ontario and the far northwest corner of Minnesota too. So that's all snow. We suspected it might be further. It's 38 over 25 at Minneapolis. Wow, that must be pigeon-sized snowflakes falling there. You know, they're all sticking to each other and they're barely staying as ice. Oh, that's cool. Didn't we have that? Somebody said we had really big snowflakes the other day.
Amazing.
Would like to see that.
Yeah.
The biggest ones I've ever seen, Angela, maybe you've seen them there too, is in Seattle. When you do get those really wet 38 over 28 sort of days.
Yeah, it was very similar yesterday.
Is that right?
It was among the biggest I've ever seen.
Man. Anybody take any pictures?
Oh, yeah.
Oh, good. I got to see them. I mean, they're the kind you can put on a plate and put syrup on them and think you got a pancake. That's what makes and then in the eastern seaboard, it's not raining anywhere on the coast as we saw earlier. But can we slide down to the south? On Wednesday, it was 90 degrees in Tampa with a dew point in the high 60s. Today it's 76 over 41 with a northwesterly zephyr. Probably a perfect day for people down there. Maybe they even donned jackets. They were talking about wearing jackets just because it was raining. I'm thinking, oh my God, you guys, something's got to change for you people down there. I feel bad.
I was in Southern California last week, and people were putting on puffy winter jackets when it was 68 outside. So
I just can't even imagine that. I wouldn't be able to hold my tongue. I like looking at low dew points too occasionally. We're well behind the cold front, which is off the coast of Florida. Look at some of these dew points in the interior of Texas. 80 over 18, 78 over 22, it's 75 over 21 at Lubbock, and 66 over 29 at Amarillo. And then south of Lubbock, 74 over 4. I mean, it's like you put water on your skin and it vaporizes before your eyes. That must be pretty awesome. So pretty interesting to look at those on days like that. I guess it means you can see forever.
Central Texas has also had a lot of, or the fire danger is really high. And
Oh.
last week, there were also some major fires down in kind of that Central Texas area.
Oh, was that right? Yeah, yeah.
So
So
before the storms happened. So in addition to those, we're dealing with, large fires.
yeah, I didn't think about that, but that's an excellent point. This is the kind of air that just desiccates fuels on the ground. I mean, just rips them apart, dries them out to bone dry. Pretty
It
awesome.
seems that that's more It's not as much of a dryland thing with the mountains as it might typically be. The first picture, the first satellite picture you showed that big gigantic dry area.
Yeah, right.
Over there.
Yeah, and top of the atmosphere dry too, it's not, yeah, so
I mean,
this is just deep
It's
dry.
a deep, dry region.
That's right. Yeah, there's no sense at all of a lee-side trough signature here, which very often is accompanied by that kind of rapid drying on the backside, but not today. Okay, I think that's the only things we wanted to look at across the country in terms of precipitation. Let's take a look at the West Coast satellite image, and then we'll go to upper level charts and see how we can piece some of this observations together. This is a continuation of what's been a very boring series all winter long, in my opinion. We just don't see anything well organized, put together in the extratropics. This is an interesting subtropical feature, of course. This is all of these little spoke-looking lines of convection that Greg's talked about before, and they probably have some relationship to jet features, which we'll see on other maps, perhaps at least their eastern extent. But overall, one gets gleans a couple of pieces of information out of this. First, little cyclone here in Bristol Bay region, I guess, is interesting. Widespread cold air in the lower troposphere, of course, because you've got this open cellular convection underneath. Big ridge building around the date line, and look at it. I mean, you don't often see clockwise rotation in clouds on that scale, but once in a while you do, and this is the case like that. So that's really neat. And but no particularly well-developed disturbance downstream of that big ridge, and maybe not even one upstream, although it's hard to tell from this. We might go back to iMerge and see actually if there's anything upstream in the Pacific. Okay, so I guess a relatively boring satellite picture, and as I said, you know, for my liking, it's been like that more often than not this winter. It's just been one of those winters, it seems like. At least my every other day check-in on it with some sense of scrutiny has given me that impression. So that's too bad. Okay, let's take a look at our upper level charts, Pete. If we can start with the Super Pete at 500 millibars. So trying to understand how all those little disturbances that we saw both in the satellite and in the radar reflectivity might fit into a broader scale picture. Maybe it can't be done with just one image, but one does get the sense that there's a deep and not particularly well-structured upper trough, not well-structured at its center. But look at all the little wiggles in the geopotential height line. All of them, I think, are fairly well supported by wind direction changes as well. So we got one here, another one here, a little more obvious shortwave, and then on the front edge of what looks like a really cold pool sliding southward is the next one. And so embedded within this rather shapeless flow over the Ohio River Valley, I'm sure there's plenty of little disturbances as well that just don't get resolved by the network. Can we go back a couple of days, Pete? Maybe look at 12Z on the 24th? See what that looks like? Yeah, so here's 12Z on the 24th. A northwesterly flow at 500 millibars. Wave one, another little ripple here, one here, and this may be the great red spot you were talking about. So one can see some evidence. It isn't striking evidence, but one can see some evidence of a variety of smaller scale features. And again, all of them supported by changes in the wind speed. This one certainly is. This one down here is. That's about a 30 or 40 degree wind speed, direction change, sorry. And then this is a pretty decent baroclinic zone at 500 millibars, along which there are little disturbances. And that's probably where we saw our most sizable of those features in the water vapor image. So it's sort of a potato-shaped upper trough with a whole bunch of little disturbances on its periphery, and that seems to be how it looks even in the regular analysis, which is nice. Dave, I've got your thesis. I got to get that to you. Anyway, that's interesting. Let's take a look at 300 millibars, if we could, at the current time. So at 300 millibars, we have a northwesterly flow upstream of us, 110 or 119 knots across the border of North Dakota and Montana, and then a strong northerly flow, a northward directed flow, southerly flow along the Atlantic coast, 150 knots over Pennsylvania, parts of New York State, and then a rapid turn. Too bad we can't see more of what's out over the Atlantic, but we know there's a big storm south of Greenland, which is probably right at the base of this trough right here. So. And then further to the west, a fairly impressive jet feature, 179 knots at the latitude of coastal British Columbia, and the sharp upper trough downstream of it. And so this must be from the West Coast satellite image, the tremendous ridge we saw that was building at about the date line. And there's even, as you remember from the satellite picture, clockwise rotation in the clouds on the anticyclonic shear side of that anticyclonically curved jet. So the map projection throws you off a little bit on that. That's an interesting feature. Okay, going back to what were we at before? 500 millivolts. Let's go back to 500 millivolts. One doesn't really see the depth of the cold here, but if we go to 500 again, we'll see what we're in store for. This is pretty chilly air. So this is below minus 25 on this isotherm. This is the minus 30 isotherm right in there. And so it's pretty chilly. Looks like it might be supported by reinforcements to the north and west. So, and that's bearing down on the central plains and western Great Lakes states. Let's see what this looks like at 700 millibars and then at 850 as a prelude for what's coming this weekend. So, minus 34 south of the archipelago in the far western part of the Northwest Territories, and strong cold advection at 700 millibars right through Lake Winnipeg. So this is really strong, advancing cold air, and we've got a sharp edge to it just on the border of our state with Minnesota, and then also into northwest Iowa at 12Z, again characterized by cold advection. So this is an advancing cold air mass that's headed our way, and it doesn't look like there's going to be much to stop it. Will we get into the depths of the very coldest air that's further to north and west is a question. There's no question we're going to get noticeably colder at all levels of the atmosphere as this day progresses. Let's go to 850 and see what it looks like. So 850, one sees roughly the same picture of minus 31 near Great Slave Lake. That's about as cold as you get at 850. And then strong cold advection all the way now easily into the southwest part of our own state, but stronger to the north and west. So we stand to get continuously colder. In fact, the central streamline of the strongest winds cutting across the isotherms is going to go right south of us to Platteville if nothing changed in this flow. So I think there's no way we won't get colder than we are right now. So any drizzle or rain that's falling now could well turn again into snow by the end of the day, or certainly sometime during the day tomorrow. And for me, the question when I see something like this is, how long will such a thing persist, and will there be any tendency for sort of a resupply? The resupply question is really a hard one to have high expectations for. The sun is up at all these places now, and it wasn't even a week ago, but it is now. And so it just gets harder and harder to really manufacture or even maintain already previously manufactured cold air. We can move it around, but it's going to be modified as it's moved around. Will this be the last really deep cold pool of the year? I don't know.
The main center of the stratospheric polar vortex is now shifted over to Siberia.
So it's on the other hemisphere.
It's in the other hemisphere, and I haven't looked at lower values of wind, but maybe there's some piece of it that's still sitting over Hudson Bay. I don't know, but it's not a major feature right now. This stuff is all kind of on its own. It's not connected with anything.
Yeah, it was maybe produced by a prior connection, but now it's been cut loose and
It's orphaned,
it's on its own for now, and it's being radiatively forced in the wrong direction for sure. And so you got to expect it's about the last one. Though when we look at the medium to longer range forecast, we don't really see spring here through at least April 5th or 6th. In fact, I'm not saying that I see it at that point. That was just the end of the horizon. So,
well, let me say this. I planted pansy flowers last week, and they're doing just fine.
Oh, that's good. That's good.
So the cold weather plants are already surviving this current weather.
Yeah.
It's spring. It's just not a warm spring.
Yeah, it's not really bad outside, and I heard people talking about planting lettuce, which is kind of frost-proof a little bit anyway, and they're having good success with that. The rabbits aren't particularly frost-proof, though, so they'll be out there finding your lettuce if you don't do something about it. So maybe this is the last piece. I don't know. I'm not prepared to say that it is. But it certainly is a menacing piece, nonetheless, for the weekend, it looks like. Let's see what it looks like at 9:25, Pete, just for fun. I don't know if it was Bryson or if it was Horn or if it was a combination of them transferred down by legend. But somebody supposedly said in our department, nothing separates these pools of cold air in high Arctic Canada from the western Great Lakes states but barbed wire and some grass. So I don't know who said it, but I wish it was me. This is really strong cold advection. The lower you get, the further back you push the boundary a little bit. And so the boundary is now at the border at 925, but it's a really substantial cold air mass that is sliding right towards us here at 12Z on Friday morning. So let's see what happens on the weekend. I suspect it's going to be chilly. And we won't go through the meteorogram, or whatever it's called. Michael, sorry, no meteorogram.
This might actually dive into the southern US. I mean, this looks like it could get to Missouri.
It looks like that, and it turns out in the forecast it doesn't quite do that.
No.
So that I don't understand why, but it's just the nature of this particular development. Okay, I suppose that's probably enough for the current weather. We look at the conditions that are laying around. So let's go to the forecast. And since the cold air is really going to be the question of interest, let's begin at 850 millibars. At let's say, what is that 6-hour forecast going to be? 18? Oh no. I wondered if this would be fixed for the discussion. Maybe it is.
Try the 69.
I had problems with both this morning getting ready for class.
That's
Yeah.
pretty good. All right. Now back to the drawing board on that one.
Yeah.
The old version.
I think I was able to look at the GFS 104 grid to 5 days or something, and that was available, but it wasn't available on the 16-day or the 8-day. Now, this is January 4th was the last time this was updated, so we're on the wrong day.
That's not it. All right, pivotal it is. Amateur hour.
Okay, so this is a nice map actually right here. We can start with this one. This is valid at right now. It's it's the initialization. No, it's a 6-hour forecast valid right now. So okay. So here's our 1,500 thickness in dashed blue. Wherever it gets higher than 540 decameters, it turns red, so that's 546. And here's the cold pool, and a sort of a deeper representation of it. This is all the way from 1,500 millibars. That's a cold pool. And on the front edge, it's snowing, and that's what we saw in our own state with the reflectivity. We didn't really see too much. Well, we did see evidence of snow in Minnesota. Sorry, we looked for that on purpose. And so that's this back piece underneath the coldest air. And the front piece is through on Western Ontario is right on the front edge. So strong cold advection by the geostrophic flow of the mean isotherms in the layer. And so that's definitely the situation we have confronting us right now. Let's step ahead 6 or 12 hours. How about 12? So this gets us to midnight tonight. The coldest air, at least in the thickness cold pool, is just moved past us by that time, and it's sitting over northern Indiana, and it's bringing along with it convective snow showers. So we will certainly see convective snow showers over our area later this afternoon into the early part of the night, almost no doubt, because that's seemingly tagged to this cold pool, and this might be enhanced by its moving over the lake, so this might be a little more than we'll see. The deepest cold air is still well back to the west, and one starts to see this kind of a strong line of baroclinicity that is oriented northwest to southeast. Maybe it starts to give a hint that this cold pool does have a chance of sliding off to the east of us, northeast and then southeast of us. You'll see.
That 540 thickness line is over Tennessee.
Yeah, that's pretty cold.
That's pretty cold for
darn
them this time of year.
I would guess that's way below the climate. St. Louis is 534, which I'm quite sure is well below the climate for St. Louis at this time of year. So this is pretty chilly. And it's not really unusually warm to the south and west. 576 thickness over Tucson, that's nothing. They're usually in the 580s to low 590s, and then heading towards 600 or something, in July. So, yeah, cold and not really counterpunched by really extreme warmth to the south and west. Let's go 6 hours ahead of this beat, so we'll get to Saturday morning. And you can see the progression of the coldest air, and it does really seem to have convective snow associated with it. Again, it might be enhanced by the lakes. We see a drop in our thickness from now, it was 525-ish or something like that. We're probably getting closer to the 522 line, which is still finding its way southward. You can imagine this is still strong cold advection to our west through the lower part of the troposphere. And but there's the pool of the coldest air. Let's go another 12 hours. So this will characterize Saturday the whole day. This is the morning, and this will be Saturday evening. And by that time, the cold pool has kind of reached the Atlantic coast in the middle Atlantic states. Our thickness has kind of gotten, stayed right around 525 for a while, and then it's going to back up to about 528. So maybe the threat of really cold airs, meaning this air, is not going to come to fruition for us on the weekend. But it's going to be a chilly weekend. We don't spend the last weekend in March in the 520s of thickness very often. Or if we do, it's a reason to not live here, right? I guess. Let's go 6 hours ahead of this, Pete, to get it, or 12 hours. Let's get to Sunday morning. Continued strong cold convection. Look at the thickness has dropped down to 522. The coldest air is to our north now, and I guess that probably does mean it's not going to make this much southward progress before it continues to make southeastward progress. We're not going to get into the depths of the cold air, would be my guess. We'll see at 8:50 how it looks. But we're going to have continued cold advection throughout the weekend. So the temperature is going to be absolutely shut down in the low 30s, I would guess, maybe even the high 20s. It just won't move much during the weekend at all. Pretty wild for this time of year. We'll go one more time because we're at noontime Sunday. Let's go to Sunday night, and our thickness at that time is, well, this is 522. We're back to about 528, so a little bit of a relaxation. And the coldest air is indeed sliding across Ontario towards the northeastern United States, not coming down over the western Great Lakes states. And very strong gradient in the thickness across the central part of North America, which very often is a harbinger of a quick warm-up, but it could also be fertile ground for a disturbance to emerge in northwesterly flow that can really spin up into a decent storm. So we'll see which one happens here.
I think that's indicative of the shallowness of this cold air. That you see that it's backed up against the mountains, but it's very, very shallow, not much deeper than what's backed up against the mountains. So it's when you get to Denver, probably the cold air is completely gone.
Yeah, that's probably right.
It's not deep enough to get to Denver.
Yeah, it's not thicker. This map here can testify to it being deep enough to look like something all the way to 500 millibars, but not above that. We don't know about that.
Yep.
Let's see what it looks like. This sequence looks like at 850. I don't know if Pivotal has a really nice 850 temperature map. It's not as good as the one Pete makes, that's for sure. Yeah, Pivotal. They don't seem to know that that's an important variable. They make great maps. Rats. Oh, what about this? Upper air, height, wind, and temperature. Oh, this is it. Okay, sorry.
No, that's not it. This is the course. I was in the wrong section.
Okay, so this is 850 millibar temperature colored in. Okay, and height and then winds. And so we're starting at.
That's 6.
Yeah, this is the 60-hour forecast. Let's go back to the 6-hour forecast. So this is the current, approximately the current time. So here's the real cold pool, and those temperatures are, we saw there's something like minus 25 to minus 30 in this range at 850. I don't know what the scale is on this one. Yeah, minus 27, minus 28. So, and poised, it seems, to come straight into along the Mississippi River Valley, which should get us really cold. Let's go 12 hours ahead here. And here's the progress of the cold air. It certainly looks like it's doing exactly that. Already here, the axis is shaded a little bit to the east of the Mississippi River Valley. And we're in the minus 12-ish range at 850. I think this morning the OB was something like minus 5 or 6, wasn't it? At 850 near northern Illinois. So it's a little bit colder. Let's keep going 12 hours ahead. So this will be noontime tomorrow. Coldest air is in far northwestern Ontario. We're down to minus 13, so that's a steady temperature at 850 pretty much. Probably cold enough to populate the sky with clouds. That'll hurt the insulation, and the temperature advection will keep the temperature, at least forcing the temperature downward. Any little bit of insulation will be trying to fight against that. I expect the temperature will stay steady. We may actually visit Michael's meteorogram later on. Or meteogram, I think they're called. Okay, let's go 12 hours ahead of that.
Can I write that down?
Yeah. Here's the cold air. It's central Ontario now. Where are we still at about minus 13? Yeah, minus 15. A little bit chillier. Temperature contrast is substantial across the Central Plains. You don't have to go very far southwest to get into very warm air. So that's a strong horizontal temperature contrast. Let's go to 12 hours, so noontime on Sunday. And I guess that's like about minus 10 or minus 11. or minus 13. So hardly a change all weekend long at 850 over us, as the coldest air slides to our north and then to our east. So we don't get bitterly cold, but we stay chilly, chillier than we are now. And it's not really that great outside right now. And then strong baroclinicity to our south and west, and also to our north and west, with a big ridge over the Intermountain West for the situation right now. Let's take a look at the 500 millibar map, starting at this time. And I'm thinking about this baroclinic zone and what it might end up being acted upon by features at upper levels. So let's see if we can get an idea of that. We probably need a bigger scale than this too, maybe a different region. Yeah, this is the continental. Okay, so let's keep in that, thanks. Let's keep in mind we have a nice baroclinic zone here. It's not hard to be reminded of that. It's a strong geopotential
You want
hypergradient.
to go back and start that now?
No, I want to stay here actually, because I'm thinking about what happens to move along this feature. Does anything come along to develop along? And here's a shear line on the cold side of it that has little geopotential height minimum associated with it. We saw a lot of that in the satellite movie and therefore in the prior week. And then this feature is nicely developed, but well to the west of the ridge that's over the Intermountain West. So how and in what way will development occur along this baroclinic zone in the coming week is a question of interest for me. I don't know if this feature will be involved, I don't know if this one will, or something that emerges around this ridge over the western part of the northern part of the archipelago. So let's step forward at 12-hour intervals. Well, first let's get to like standard synoptic times. Let's go 6 hours, so this will be 0Z on Monday. And this is, of course, the region of interest. Okay, let's go 12 hours ahead. We see the cyclone off the west coast is still making progress onshore. And this would be an interesting feature to watch in the satellite movie. There'll be all little ripples along this feature for sure on Monday. And so pretty active weather probably coming onshore in Northern California on Monday. No development, strong northwesterly flow over us at this point next week. Let's go to 12 hours right ahead of this.
Is this the stuff that you a lot of times see it called spokification? Some kind of inertial instability or something going on?
Yeah,
on
it
the
looks
side?
like it in there, because that's, yeah, I think so.
Yeah, the anticyclonic vorticity here is large.
Yeah.
And probably stability is not anything to speak of, so you get really low
So
PV.
mountain waves are just coming out.
Yeah, and they don't have any resistance at all to being bounced
I
around.
saw them back up in here earlier too. Go back to 60 hours to see the same kind of thing going on back up.
In here, you don't even need mountains. Look at this feature over here, at the downstream edge of a deep trough. The next time, the one that we were just looking at. Same feature here, and that's downstream of this trough. There's no orography, it's just you got low PV in that region probably.
Right, right.
Okay, let's go 12 hours ahead. This is now Monday night. Yeah, but this whole wave's being ripped apart as it encounters the mountains. Becomes a less coherent feature the further inland it tries to become. And we stay in the northwesterly flow. This is going to be where all the perturbations are. And some of them may, of course, come along and drop some lake effect enhanced snow across western New York, maybe even southern New England, on next to the last day of March. Let's keep going. 12 hours at a time, please. Yeah, you hardly see anything left of that basic structure to begin with, except the broad upper trough, which is still evident. And that feature is kind of making eastward progress towards the central part of the United States by about mid-morning on Tuesday. Here's another, that same shear line kind of moving in. I bet you there's a really strong upper front right there off the Atlantic coast. We'll take a look at that next week. Let's go to 0Z on Wednesday. Now we see sort of a separate upper level disturbance emerge from this broad upper trough. Here's a strong, most likely a strong baroclinic zone in the middle and upper troposphere right in that location. That's going to survive the transect across the mountains, it looks like. And here's the upper wave. So I'd say development starts, we'll check this, development's probably going to get itself going here over Kansas and Nebraska at about this time. So this will be Tuesday night.
I'll just throw out there too that the Storm Prediction Center has a day 5 outlook for Wednesday for severe weather along the Kansas-Oklahoma kind of front range dry line area associated with this. So there's questions right now of moisture return since the Gulf has kind of been affected by the previous cold front coming through, but they're already eyeing 5 days out for this trough to be a possible severe weather maker.
That strikes me as a good call. Here's a big ridge. I bet you the anticyclone's about in the Ohio River Valley, like in this region. And there won't be the strongest return flow, but there won't be anything resisting it. That's good, not good. And then you've got the elevated mixed layer over the Mexican plateau that's being scooped off of the plateau and dragged out across the plains. Everything's working in that direction. And if I'm right, that this vorticity line is really a manifestation of a strong upper tropospheric baroclinic zone. It's undeniably frontogenetically active, so you got local lifting on the warm side, right where you want it. So this could be a bad day down in the south central states.
Tis the season.
Yeah, that's right. And so let's take a break from this level, although keep it in mind. Well, let's see what it looks like at the surface on the same
Real
scale.
quick, John,
Oh, yeah.
does this seem just like a really short wavelength for this trough ridge, trough pattern?
Yeah, it is.
This
It
is
is.
short
It's like a
normally.
mega.
It is very small scale. That's a big ridge, because that spans, you know, its meridional extent on the map projection is about 1.5 times its zonal extent, so that's a pretty unusual dimension, yeah.
Okay, you wanted to go to 8?
Let's go to the surface map at this time, 0Z on Wednesday. And so here's the development that's beginning to take place over Kansas and Nebraska. And as Kelton was pointing out, the threat for severe weather looks pretty good down here. You've got a strong thickness gradient. The red lines are the thickness gradient. That's indicative of a strong horizontal temperature contrast. Troughiness in the same region, but not precisely the same region, probably means it's got lee-side type characteristics. That's going to enhance the dry line. And so this could be a really active day down over western and central Texas. 982 millibars, too, is nothing to sneeze at the surface. And you can see the baroclinicity on the eastern side is likely to be concentrated by strong southerly advection into central Iowa, and then pretty much a long isotherm, or maybe slightly warm advection across here. So there's going to be differential temperature advection along this baroclinic zone, and that will be frontogenetical. So I'd be surprised if we don't see rain beginning sometime late in the day, evening on Tuesday into Wednesday morning. That's 982 is nothing to sneeze at this time of year. That's a pretty good storm. So let's go back to 500 if we could, Pete. Keep our eye on that thing. Yeah, no need for the meteogram, even though I like it, as you know. Okay, let's go 12 hours ahead to Wednesday morning. Whoa. That makes me pretty nervous. So here's the upper trough. Here's the center of it right there over eastern Nebraska, right over Omaha. So perhaps the cyclone, I'm going to guess, given the fact that there isn't much, the curvature is well upstream and the anticyclonic curvature is downstream, that the development's probably not gone much further than 982, maybe not even at all. However, the active weather is going to be wild in the northern part of that cyclone. And whatever this thing is, and at least manifest in a temperature contrast, is going to have a lot to say about what goes on in the southeast United States. But I don't like to see these little spots of what I'm sure are negative absolute vorticity popping up here. They're indicative of a squall line in the forecast, in my opinion, because you're taking convectively unstable air, launching it upward in updrafts, and it gets up to 500 or 600 millibars, 400 millibars. It's no longer convectively unstable, but the negative PV, moist PV, has to be conserved, and the only way to do it is to have negative absolute vorticity. So that's what I think you're seeing there. So let's see if we get down to like 980-ish. And I promise I haven't looked. So let's see. Oh, no, it even fell a little bit. Wow, how do you like that? So the development ceases on this thing. Again, that's pretty far removed in this latitude from the strong curvature well to the south. And the anticyclonic curvature downstream is enough to produce upper divergence, but that's being concentrated in producing precipitation, not evacuating the mass at the surface low. So 986, that all makes sense, though I couldn't have seen it coming. And then the baroclinic zone is intense and being acted upon, and there's your squall line. So it's going to be a wild day on Wednesday here next week. We'll be in the rain, it looks like, not far from the heavy convection and not far from the snow. So the question now is, maybe 12 more hours, a couple more of these. What time we go? Okay, we can do it.
You want to go?
Let's go to 500 first. I like this game of trying to see if we can make a reasonable diagnostic of what happens next to all these features. Even though the answer is usually I can't. Here's Wednesday night. Another one of these complicated, I bet you're going to see little wave disturbances back here, and then they rotate around this upper trough just like we saw this week. But this is a very impressive upper feature. I'll bet you this is a strong baroclinic zone. We'll have to check on that with some other map in a minute. Here's the squall line again, I think, and I'm going to guess that development really has not taken off. It's probably still around 580, 986 or something, and snow to the west rain to the side. I don't know where we are. We're probably just on the edge of the convection and just a basic stratiform rain here.
Can we take a look at 200 millibars at this time?
Yeah, okay.
I'm curious what's happening. There's some jet there.
Yeah, that's right where the squall line is. That's just about where it is. Here's the subtropical jet. There's the big ridge. So there's a little bit of a wind speed max there, but it's not. It doesn't look like the most organized thing you've ever seen. What about at 300 millibars? It's a little better organized at 300. So that's the bubbling up out of the convective activity, maybe. This is the major jet feature at 300 millibars, looks like. And that's about where you might expect it to be. And then the squall line is on the anticyclonic shear side because it's easier to move the air laterally when you get there at the top. Interesting. Okay, let's go 12 hours further, Pete, to 12Z on Thursday at 500 millibars, we could? Okay, 12Z Thursday. So here we have another sort of treble clef looking structure of it in the PV. It looks like an upside down question mark. The cyclone's right here over the border of Minnesota and Wisconsin. And then here's evidence of probably what remains of the frontal structure of the storm. And maybe the squall lines moved into Georgia, South Carolina, North Carolina. I don't know if that's what that is or not, but probably it is. So let's take a look at the surface, trying to keep in mind where all those features are. And I think the storm will have deepened a little bit this time. Yeah, 979. So it's a little more intense. It's right on the border. The heavy snow's back to the west, and there's the squall line. It did look like it went through Georgia, South Carolina, North Carolina. It's not as intense as it was at the prior times, except if you're south of Atlanta. But 979, nearly over the arrowhead of Minnesota on the last day of March, is really something to be excited about if you like weather systems. That's pretty good. So this is going to be a really interesting midweek. Along about Tuesday night into Thursday, we're going to see this nice development marching northward, intensifying for some periods, not intensifying for others, and then having another burst of intensification. All of it as the upper disturbance gets a little bit better put together. The first piece of it comes across the Pacific coast. Much of that gets shredded upon going across the mountains. Enhances, though, that same progress enhances the severe threat across the southern plains, while the upper level kind of reorganizes and develops a cyclone. And then I think the stuff that comes in the northwesterly flow back behind of the main upper trough is what reorganizes a second time the upper level disturbance to deepen this storm to 979. I don't know if we've had a 979 cyclone this close to us all winter long. And here it is forecasted for March 31st.
This is out like a lamb, right?
Yeah, this is out like a lamb, if you like lamb waves. No, it was in like a lion. In like a lamb, it's out like a lion. It's totally the opposite. So that's what I have. We could go further, but I don't want to take it. You can do that on your own if you're interested in what happens a week from today. But it looks like it will be an interesting week.
Can we look at a different time forecast? I'm wondering how stable this forecast
Oh, yeah, good idea.
Oh, you mean?
I think you can, yeah.
Let's go earlier.
978.
Oh,
980, same thing. Good.
it seems to be pretty solid.
Wow, it does. This was a
What
good
about
exercise.
ECMWF?
This is, then they automatically go to the wrong time, so we got it.
Well, the 12Z is still coming in, so you just notice it.
Oh, okay.
This-
And then go back to the right time.
That's 12 hours ahead. I think we were looking, weren't we, at 12Z on Thursday? Yeah. So this puts us in the snow. This is not a big difference in terms of the global scale, but it's a difference if you live in Wisconsin. We're on the cold side. Squall line looks better organized at this late time in the forecast as well in the ECMWF, but that's snowing for us.
Wow.
I mean, it could be a wild week. That just adds a capital W to wild for me right there. So it's worth looking around for what's coming. But it's not going to be boring, let's put it that way. It's not going to be boring. And neither is this. This isn't boring. This cycloneless front, which has a really nice precipitation signal, it's embedded between two giant anticyclones. That is really interesting. Cool. There's always something to look at. So Pete, thanks for driving and expertly bouncing around these different maps as you did and making the adjustment to the fact that the super Pete's weren't in for some reason. And thanks everybody for coming, and we'll see you all next week.
It's interesting.
It is gonna be really interesting. I'm
None of
excited.
this is